Now, a lot of times when you're talking weighted average, you'll have to work with percents. So instead of getting the number of things, you'll get the percentages of them, like right here. Here's how you calculate a weighted average using percents. Okay. What I'm going to do is I'm going to take the weight of the Lamona G here, and I'm going to multiply it by 73% expressed as a decimal. So the decimal place in 73% would be here. To turn this percentage into a decimal, I have to move the decimal place 2 spots to the left. So I'm going to move it to here, okay? And the decimal place is going to end up right here. So I'm going to do 0.73 and then multiply that times the weight, 3,000 pounds. That's the Lamona G. Now for the GX, I'll take 11% and express that as a decimal. Move the decimal place 2 spots to the left, so it's going to end up here, 0.11, and multiply that times the weight of the GX, 4,000 pounds for that model of the car. And finally, I'll take 16% and express it as a decimal, 0.16, and multiply it by the weight of the GXL model. Now, when you're working with percentages, you don't divide by anything. All you do is multiply the weights by the percentages expressed in decimals, and that's all you have to do. This is the same problem as the one that I did before. We're just expressing these abundances, or the amount that we have, in percents. So the answer, 3,432 pounds, is going to be the same as what we got earlier. Anyway, that's how you do weighted average using percents. Now, I have to say this. Weighted average doesn't mean that you have to use weights of things, all right? You can calculate a weighted average with the amount of money people make, or like how much volume you have in different types of containers. Anything you can think of, any measurement you can think of, you can do a weighted average of. So I've been using examples of weights here, weights of people, weights of cars, but you don't just have to do weights for a weighted average. The only reason you call it a weighted average is because it takes into account the number of each thing you have, and they kind of pull the average closest to their value. So that's why you call it a weighted average, because you give different weight to each type of thing that you have. Finally, if you're interested to see how this equation here is the same as the one that I did here, you can finish this video up. I'll show you at the very end how these are equivalent expressions. So these two expressions are equivalent ways of writing the calculation for the weighted average for this information here. Let me show you how they're equivalent. We're going to take this and we want to end up with something that looks like this. The first thing we can do is we can see these 3 different things that are added together on the top of a fraction. We can separate them out. Okay, so I'm going to do 32 times 3,000 divided by 44 plus 5 times 4,000 divided by 44 plus 7 times 5,000 divided by 44. Okay, so I can split this into 4 pieces. I can split this into 3 pieces. Each of them have the same denominator. Now, take a look at this. I've got a number over 44 in each one of these cases. And this is kind of a percentage, because 44 is my total. And each one of these numbers in the numerator are fractions of that total. So what I can do, since these are multiplied together, is I can divide this and then just keep it multiplied by that. So 32 divided by 44 gives me 0.73. That's this part, times 3,000. I can put that in parentheses. Now I can do 5 divided by 44, and that gives me 0.11. And I'm going to multiply this now times 4,000. Put that in parentheses. And finally, 7 divided by 44 gives me 0.16 times 5,000. And check it out. What I end up with when I split these up and I do this division is exactly the same as the number that I get when I take these values and use the straight percentages here. So the point is, whether you choose to use the individual numbers of each thing you have, or whether you choose to use the percentages, the way you go about calculating the weighted average has the same math in it. Anyway, now that you know how to calculate a weighted average using the numbers of the things or the percentages of the things, you can now go on and learn how to calculate atomic mass.